Hello ladies and gentlemen, this is Ms. Skokin, back in geometry. This time we're in section 4.2, classifying triangles. Our objectives are classify triangles by their angle measures and side lengths, and use triangle classification to find angle measures and side lengths. For vocabulary, we have acute triangle, equiangular triangle, right triangle, obtuse triangle, equilateral triangle, isosceles triangle, and scalene triangle. Obviously, we're going to be working with triangles, and we need to pay attention to the details. We're going to start with a warm-up, and you are going to classify each angle. I'm going to ask you to pause the video and turn it back on when you're ready to check your answers for questions 1 through 4. Questions 1, 2, and 3 were straightforward, just classifying the angle. Question number 4 was also straightforward, but you might have had to think about that one just a little bit. We have 3 different expressions for the 3 different lengths on this triangle, and we know that the perimeter is 47, so that means that they all add up once we add those up to 47. Once we set it up as an algebraic equation, we can easily solve for x, which ended up being 5, and we plug 5 back in to each of the different expressions to end up with the lengths, the 3 lengths of the sides of the triangle. Okay. So a triangle is a polygon with 3 sides, and we can classify triangles in 2 different ways, either by their angle measures or by their side lengths. And we can see a triangle ABC in the diagram. The points A, B, and C that make the triangle are called the vertices of the triangle, and they always, remember, our notation for points are always capital or uppercase letters. The 3 sides of the triangle are segments. We have segment AB, segment BC, and segment AC. Once again, remember the notation for segments so that you can write the sides of the triangle correctly, or if you're trying to give the side length, it's not going to have the little bar over it. And just a caution as we go through this triangle unit, be very careful. Pay attention to whether you're talking about the sides or you're talking about the angles. Different rules for the 2 of them. When we classify triangles by angle measure, we're looking to see what angles make up that triangle. And when we have an acute triangle, we have 3 acute angles. With an equiangular triangle, we can see the word angle in there. That means we have 3 congruent acute angles. When we have a right triangle, we have 1 right angle and we have 2 acute angles. And when we have an obtuse triangle, we have 1 obtuse angle and 2 acute angles. In example number 1, we're going to be classifying triangles by angle measure. But you need to be cautious and make sure you're looking at the right triangle, because we can see that there are segments drawn within each of these triangles. And so what I recommend that we do is we color in which triangle we're looking at. For the first question, question A, we want to look at triangle BDC. Triangle BDC is the one I've colored in red. We want to classify the triangle acute, right, or obtuse. And although it is a little bit hard to read, we can see that that angle DBC is measuring 100 degrees, making triangle BDC an obtuse triangle. On question B, the triangle of interest is triangle ABD, which is the little teeny tiny triangle that I have colored in. This one we can clearly see is an acute triangle, which we know because all 3 angles are less than 90 degrees. Question C is looking at triangle EHG, which is the triangle highlighted in green, and we notice that this one has the little right angle symbol. So that means we have a 90-degree angle in this triangle, making it a right triangle. Our next triangle of interest is triangle EFH, which is this triangle highlighted in blue, and we can see a linear pair right here with 60 degrees on the right-hand side, and that means that the missing angle in the left-hand triangle has to be 180 degrees because we have an 120 degree angle in our blue triangle. We know that it is obtuse. And our final triangle on this page is triangle FHG, which I've colored in orange. We can see that two angle measurements are given, 60 degrees and 60 degrees, and then we see we also have a 90-degree angle with 30 degrees making up part of that angle for triangle EHF at angle EHF. That means what remains out of the 90 degrees for angle FHG is 60 degrees. We have three equal angles, and that makes this an equiangular triangle. So we have classified all the triangles in example 1, and we're going to move on to the next page. Here we see that we can also classify triangles based on their side lengths. If we have three congruent sides, that means we're going to have an equilateral triangle. If we have an isosceles triangle, that means we have at least two congruent sides. And what that tells us, that wording tells us that the equilateral triangle is a type of isosceles triangle, but it has three congruent sides, not exactly two congruent sides. Scalene, we have no congruent sides, so all three side lengths are different. In example 2, we're going to classify our triangles. Once again, we're going to highlight which the triangles are, and then we're going to classify them, but this time by the side lengths. So for question A, we're looking at triangle EHF, which is the triangle on the left. And we can see that this one has two congruent sides, making this an isosceles triangle. Question B refers to triangle EHG, which is marked here in orange. We can see that we have three different side lengths, 10, 11, and 12. So since all three side lengths of this triangle are different, that makes this a scalene triangle. Question C refers to triangle ABC. On this triangle, we can see that we have a length of 15 on one side, but we also see that we have the tick marks telling us that the side on the right-hand side is also measuring 15. And last of all, we've got the third side also measures 15. So we've got three side lengths of 15, making all three sides equal. So this is an equilateral triangle. Last of all, we have question D, which refers to triangle ABD. Triangle ABD has one side length of 15, has another side length of 18, and has a third side length of 15 plus 5, or 20. That means that each of the three side lengths on triangle ABD is different length, so that makes this a scalene triangle. We have successfully classified triangles by their side lengths. Let's move on to example 3. In example 3, what we're going to be doing is using the triangle classifications. So we have information given to us, but we don't have all the information. So what we're going to try to do is use our algebraic skills and our knowledge of geometry to determine what the missing values are. The instructions say find the side lengths of the triangle using the given information. And what we see immediately is that side JK and segment KL are congruent, which means that their lengths are equal. And since we have expressions for each one of those side lengths, we can substitute in for those. Once we've got the equation set up, we can solve for x. So we're going to have 4x minus 2x and 10.7 plus 6.3, giving us 2x is equal to 17, and that means x is equal to 8.5 or 8.5. Now that we've got that, we can plug in for x in each of the three side lengths. The length of segment JK is 4x minus 10.7, so we plug in 8.5 for x, and we end up with JK having a length of 23.3. Now we can do the same for KL, which measures 2x plus 6.3. We substitute in our found value of 8.5, and we find that segment KL has a length of 23.3. Now we're going to do the same for JL, which measures 5x plus 2. Substitute in, and we find that side JL has a length of 44.5, and that means we're ready to move on to question B. Here again we have two congruent sides, which means that the side lengths are equal, and because we have expressions for both of those side lengths, we can plug in. Once we have the algebraic equation set up, of course we can solve. So we're going to have 4x minus x on this side and 1.3 plus 3.2 on this side. That means that 3x is equal to 4.5 and x is equal to 4.5 divided by 3, which is 1.5. And now once again we can plug in what we found for x into each of the expressions and find the three side lengths. JK is equal to 4 times 1.5 minus 1.3, giving us a length of 4.7. We know that segments JK and KL are the same length. So that means we already have the length of KL because those sides are congruent. So we have 4.7. The last one that we need to find is the length of segment JL, which measures 5x minus 0.2. So we substitute in, and we end up with a length of 7.3. And we're done with questions A and B and ready to move on to question C. Question C says, find the side lengths of the equilateral triangle. So that means that we know that these three side lengths are equal, and we can use that information to set up an algebraic equation. Let's start out by writing segment FG is congruent to segment GH, and that means that the length of segment FG is equal to the length of segment GH. And now let's substitute in. So FG says 3y minus 4, GH says 2y plus 3. And again, we have an algebraic equation that we can solve. So we've got y is equal to 7, which is great because now we can plug y into all three lengths or only into one because we know that they are all the same length. So FG measures 3y minus 4. We substitute in our 7 that we found, and that's going to be 21 minus 4, or 17. That means that all three sides are length 17. So we are able to classify triangles by their side lengths and by their angles, and we're able to solve problems with that knowledge. Let's take a look at our last example before we hit homework. Example number 4 says music application, and we'll read it together. A manufacturer produces musical triangles by bending pieces of steel into the shape of an equilateral triangle. We can see the side lengths are 4 inches all the way around the triangle. Then it says the triangles are available in side lengths of 4 inches, 7 inches, and 10 inches. So there are 3 different sizes of equilateral musical triangles. We want to know how many 4-inch triangles can the manufacturer produce for a 100-inch long piece of steel. So in total we have a 100-inch long piece of steel. Each of the 4-inch triangles needs 3 times 4 or 12 inches to create the triangle, and that is the perimeter of the 4-inch equilateral triangle, 12 inches. So what we need to do is take the 100 inches and divide by 12 inches, giving us the number of triangles, which turns out to be 8 1/3. Now we know no one is going to want a piece of a triangle, so that what that means is we'll have kind of one side length left over. So really what we can do is we can make 8 4-inch equilateral musical triangles. So that's our music application. We're ready for homework now. I will see you back in class.